Okay, powers and exponents. Let's talk about that. We did this in sixth grade, so let's go back to just the foundation of this. If we remember something like, let's say 2 to the third, right? We have some pieces here, and the pieces are, this piece right here is described as the base. That's our base. Then up here, this one here, this is our exponent. And what that means is the exponent tells us how many factors of the base there are. So this says 2 to the third, so we would say this as 2 to the third power, hence the word powers. 2 to the third means that we have 2 as a factor 3 times. 2 times 2 times 2. So the equivalent of 2 to the third is 8. 2 times 2 is 4, times 2 is 8. Okay, so when we're evaluating powers here in exponents, what we're looking for is what's the base and what's the exponent. So if we put this into an algebraic sense, if I said x to the fourth, that's the equivalent of saying x times x times x times x. Now just a reminder, remember this is not the same as 4x. So I want to just let's put a big caution sign here and say not. Okay? What it isn't is 4x. This says x times x times x times x. X times itself 4 times. This says 4 times x, which is just 4 times x. Now, multiplication in this sense is repeated addition. So it is also the same as x plus x plus x plus x. These two are equivalent and not equivalent to that. Let's look at how we evaluate powers. So if we have multiple digits or multiple factors of the same digit, we can write those as exponents to make things more clear. Let's look at the first example here. We've got -4 times -4 times -4 times 5 times 5. So I've got 3 factors of -4, so I'm going to rewrite that as -4, but this is important. The parentheses matter here. -4 to the third, because that means it's -4 times -4 times -4. That exponent there goes to the negative sign as well. So I have -4 to the third times, and I have 2 factors of 5, 5 to the second, or 5 squared. Here I've got a times b times b times a times a. I can rewrite this, so I just get my terms together to say a times a times a times b times b. I have 3 terms here. I have 2 terms here. That gives me a to the third times b squared. 2 to the, what? 2 to the 7th raised to the third? All right, let's just write it out first so we can get an idea of what this means. So this is the same as 2 sevenths times 2 sevenths times 2 sevenths. Now, remember the algorithm for multiplying fractions is you multiply your numerators together, you multiply your denominators together, and you're good to go. So I've got, for my numerators, I've got 2 times 2 times 2, which is 8. But my denominators, I've got 7 times 7, which is 49, times 7. All right, so 50 groups of 7 would be 350. I only need 49 groups of 7, so that's 343. So 343. What did you notice? All right, the thing that you might have noticed was we did the same as 3 factors here, right? So this is 2 to the third over 7 to the third. It's the same thing. So that parentheses helps us to distribute that exponent to both the numerator and the denominator. Now let's evaluate them in an algebraic sense. So, oh no, I've written all these wrong. Now let's evaluate these in an algebraic sense. So I have values for my variables. X is going to be equal to -2, y is equal to 3. And now I have some expressions here. And expressions are equations without equal signs or answers. So what we're going to do is we're going to substitute in the values, and then we'll use the order of operations to figure this out. So in this first one, I'm going to substitute in for x, -2. Now when I substitute in, I'm always going to put the parentheses. The parentheses make a difference. It helps me remember that the number isn't 2, but it is -2. So parentheses -2 plus, and I'm substituting the y in here, I'm going to say parentheses 3, and that whole thing is raised to the 3rd power. So we do the grouping first. -2 plus 3 is +1, and we still have it raised to the 3rd. Well, there's a twist. I made it a little too easy. So I got 1 times 1 times 1, which is equal to 1. Well, that's what I get, right? All right, and let's try this one now. This one, cross your fingers. This one won't, that same thing won't happen. So here we've got an equivalency. We're going to say -2, don't forget your parentheses, raised to the 3rd power, plus 3, parentheses, raised to the 4th power. So now I've got -2 times -2 times -2 plus 3 times 3 times 3 times 3. All right, -2 times -2, going back to 7th grade, that's +4. +4 times -2 gives us -8 plus 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. -8 and 81. When I combine those two, they're gonna battle, right? So we're gonna have 8 fewer than this one here. So that value is 73. Let's look at a special exception. So what we have up here are 2 different evaluations here with exponents. The first one says the opposite of 3 to the 3rd. The next one says -3 to the 3rd. So in the first one here, since the negative and the number are not grouped together with the parentheses, this exponent is only going to apply to the base here. It doesn't apply to the negative sign. Let's look at a special exception. So we have 2 similar bases, and the exponents are the same, but the evaluation of these are different things. So in this one, this says the base is raised to the 2nd power. This one says the base and the negative, because they're grouped together in the parentheses, are raised to the 2nd power. So in this, we have 3 times 3 raised to the 2nd. So that 3 is the only thing that applies to that. So that will end up being -9. 3 squared is 9, and that negative sign just travels down with it. In this one, we say this expression here is entirely raised to the second power. So what in reality what I have is I have -1 times -1, that's your negative sign, times 3 times 3. So -1 times -1 is +1, and 3 times 3 is 9, which gives me +9 for the result there. That's a little bit more technical than you probably need, but just remember the key to this is if the grouping is here, the exponent applies entirely to the grouping. If there's no grouping, then the exponent only applies to the base. It does not apply to the sign. All right, last thing, let's look at the vocab. Today's vocab, we got 3 words today. We've got base. We've got exponent. And we've got a power. Or powers. That seems to always be plural. I don't know why. All right, so a base we know is the factor being multiplied. The exponent then is the number of times we have the, let's change this to number of factors. That makes more sense. Number of factors. And then the power is the result in exponential form. So an example of that would be if we had a base of 7. That's our base. Then we had an exponent of 3 exponent. Then this whole thing, the two of them together, that is the power. I have the power. Okay.